Hey everyone, I'm Praveen and welcome to AI Sparks, where artificial intelligence meets innovation and excitement. On this channel, we spark curiosity and ignite imagination with AI-powered insights, tutorials, and explorations. From machine learning to robotics, we'll dive into the future. Today, imagine you have a brilliant research idea, but turning it into a full scientific paper feels like assembling a puzzle blindfolded. Today's story is based on the paper Story2Proposal, a scaffold for structured scientific paper writing by Zhuoyang Qian, Wei Shi, and a team of researchers. Here's the problem. Generating a full academic paper isn't just writing, it's coordination. Introduction. Method, experiments, figures, everything must align. But most AI systems today, they generate text in one go, and that leads to chaos. Sections drift, figures go missing, claims don't match experiments. It's like building a house without a blueprint. So what's the core idea? Story2Proposal treats paper writing not as text generation, but as a structured construction process. Instead of one AI, it uses multiple agents, each with a role. Architect designs the paper structure, writer drafts sections, refiner aligns everything globally, renderer produces final latex. But here's the magic. They all share something called a persistent visual contract. Think of it like a shared checklist that tracks sections, figures, tables, and rules. So every agent knows what must exist, where it goes, and how it connects. And during generation, evaluation agents constantly check, is the reasoning valid? Are figures aligned? Is structure consistent? Then they update the contract. This creates a loop. Generate, evaluate, adapt. Let's break the pipeline quickly. First, the architect takes a research story and converts it into a blueprint. It defines sections, claims, and even registers figures. Then the writer generates each section but strictly follows the contract, no random structure, no missing references. Next, the refiner steps in. It aligns everything globally, fixes inconsistencies, compresses redundancy. Finally, the renderer ensures every figure appears exactly once, labels are correct, and the paper compiles cleanly. So instead of hoping things work, this system guarantees structure. Now, how well does it actually work? The researchers tested it across multiple models, GPT, Claude, Gemini, Quan, and compared with two baselines, DirectChat and Farce. Results: Story2Proposal scored 6.145 versus 3.963 against DirectChat. That's a massive jump. Even against a structured system like Farce, it still improved performance. Experts reported better structure, clearer experiments, and stronger alignment between text and visuals. So the key takeaway: structure beats raw generation. But it's not perfect. Here are some pitfalls. First, if evaluation agents miss subtle reasoning flaws, the system might produce a well-structured but weak paper. Second, it depends heavily on input quality. If your research story is incomplete, the output will be consistent but incomplete too. So structure doesn't replace knowledge, it just organizes it. Practical tip: if you are building similar systems, start by designing a strong intermediate representation like this contract. That's where most of the reliability comes from. So here's the bigger idea. AI writing isn't just about smarter models, it's about better systems. Story2Proposal shows that when you add structure, feedback, and collaboration, AI stops guessing and starts building. And the real question is, what happens when we apply this to entire scientific discovery pipelines? If you found this helpful, hit like, subscribe, and comment which AI system you want to build next. Stay sparked. See you in the next video.